This lesson is on solving literal equations. As you can see from these examples, literal equations have more than one variable in them. It's always going to specify which variable it wants us to solve for. You're not going to get pretty answers like y equals 7 for these kinds of equations. You're going to get ugly answers, but your job is to solve for whatever variable they tell you to. So if we look at number 1, it tells us to solve for y. So my job is to get y by itself. Okay, so if I look, here's my little wall, and here's my y. So I have to ask what's with my y on that side of the wall, and the answer is a positive 3. So it's y plus 3. So to move that 3 away, I'm going to subtract 3 from both sides. Now on the left-hand side, I can't actually subtract a 3 from an x, so I just write x minus 3. And then on the right-hand side, I just have a y left. So my answer is y equals x minus 3. I have gotten y by itself. Number 2, solving for z. Here's my z. What's with my z is a minus 5, so I'm going to add 5 to both sides. Those are going to cancel. On the left-hand side, I have w plus 5, and on the right-hand side, I just have my z. Make sure your z's don't look like your 2. And then I'm just going to flip it around and put the z in the front and make it w plus 5. Number 3 says solve for t. So here's my t. What's with my t on that side of the equals is an r. They are being multiplied together. So in order to move that r, I have to divide by r. I do the opposite of multiplication. That causes these to cancel. On this side, I have d over r equals t. If you switch it around, you'll have t equals d over r. Number 4 says solve for r. What's with the r is a 2 and a pi. They are all being multiplied together. So to move the 2 and the pi, I'm going to divide. And I'm going to do it in one move. That causes the 2's to cancel and the pi's to cancel. I now have r by itself, and what I'm left with is c over 2 pi. So I have r by itself. Number 5 just takes this concept and puts it in a word problem, which is what the final exam really likes to do. It makes you have to read for it. It says energy and mass are related by the formula E equals mc squared. M is the mass and c is the speed of light. Which equation, and this is the important part, finds m given E and C? Well, this finds m is telling you who it wants you to solve for. And you can also look at all your multiple choice answers. They are all m equals. So it's telling me to solve for m. So I take this equation and I need to solve for m. Well, what's with the m? And that's the c squared. And they are being multiplied together. So to move it, I'm going to divide by c squared. C squareds cancel. And I have m equals E over c squared. Try to find that in the multiple choice. And it's D. Solve for x. So here's my x. What's with it is a z cubed. It's being multiplied, so to move it, I'm going to divide. So I divide both sides by z cubed. So I have x equals y over z cubed. Okay, 7's a little different. It says solve for p. Let's change this to solve for, let's solve for f. Okay, in order to solve for f, what's with the f? Well, currently it's being divided by a. So what is the opposite of division? And that is multiplication. So I'm going to multiply both sides by what it is being divided by, which is a. So I'm multiplying both sides by a. These are going to cancel. I now have f by itself. And on this side, I have A times P, so AP. Power and work are related by the equation P equals W over T, where W is the work and T is the amount of time. Which equation gives W in terms of P and T? So the whole gives W, that's what you would highlight or box in, and that tells you what you're solving for. Now, if I look at my multiple choice answers, are they all solved for W? The answer is no. B is actually solved for P. So I know that B is not one of my answers. So then I take the original problem, and again it wanted me to solve for W, so what's with the W, and that's the T, and currently it's being divided by T, so I'm going to do the opposite of that, and I'm going to multiply both sides by T. That causes these T's to cancel, and I have W equals, and then on this side I have T times P. So let's find an answer that says W equals T times P. And the answer is A. Even though I have T times P and they have P times T, that's the same thing. Multiplication, you can flip them around. It doesn't make a difference. But I know it's not division, and I know there's not a W on this side, so I know it's not that one. Okay, number 9, solve for X. So I find my X, and I ask myself what's with it, and that's a minus 2y, so it's being subtracted. So the opposite of that is addition, so I'm going to add a 2y to both sides. So now I have X by itself equals Z plus 2y. Number 10 says solve for X. Here's my X. This one's fun because it's all letters. So I'm going to solve for X. So what's with the X is an A and a plus B. What would you move first? Well, the answer is the plus B. Just like if you were solving equation, if you had 2x plus 3 equals 8, you wouldn't move the 2 first. You would move the 3 first. You would subtract 3 from both sides. It's the same thing here. You're going to subtract the b from both sides. So now I have ax equals c minus b. Now I'm not done. They wanted me to get x by itself, and right now I still have an a with it. So how is the a with the x? Well, that's being multiplied. So I'm going to divide both sides by a. But when you divide the right-hand side, you have to make sure you divide the whole side by a. These cancel, so x equals c minus b. Make sure that bar goes all the way across, divided by a. Number 11 wants us to solve for b. Here's my b. Here's my little wall. So think about what's with the b. There's an m being multiplied by the b, and then there's a minus a. And you have to ask yourself, which one would you move first? And the answer is the minus a. So I would add a to both sides. So I have mb equals k plus a. And then to solve for b, what's still with the b, and that's an m, that's multiplication, so I'm going to divide both sides by m. And when I come over here, I have to divide the whole side by m. Those cancel. B equals k plus a all over m. Number 12, I'm solving for g. So there's my g. What are we going to move first? We're going to move the plus f. So we are going to subtract f from both sides. So I have mg equals t minus f. Solving for g, so I'm going to divide by m, whole side. G equals t minus f all over m. Now number 13 wants me to solve for m. Okay, so think about where the m is. Here he is. A lot of times when we see parentheses like this, our gut instinct is to distribute. But if you distribute the m, wouldn't that just spread the m out? And I'm solving for m. I don't want to spread it out. I want to move things away from the m. So think about this parentheses, and I don't really care what's in there, but that parentheses is being multiplied by my m. Well, that big parentheses is the part I want to move because I want m by itself. So this k plus 1 is in this parentheses being multiplied by the m. So how can I move the whole parentheses at one time? And that's divide by k plus 1. That makes that whole chunk go away because it's in parentheses. That's why I can do this. So I have m equals p over k plus 1. So again, going back to the original problem, I knew I wanted to do that because my m is sitting out here. So all I need to do is get rid of that parentheses. Okay, along the same lines, let's look at number 14. I'm solving for h. So here's h. So do we want to distribute? And the answer is no. I want to solve for h. So currently with the h is a 2 and an L plus W. So these three things are being multiplied together, the 2, the h, and the L plus W. I want the h by itself, so I need to get rid of the 2 and the L plus W. So I'm going to divide by 2. And I have to keep my L plus W in parentheses because I also have this 2 down here. So I'm going to divide by 2 times L plus W. That causes the 2's to cancel and the L plus W to cancel. So H equals A over 2 parentheses L plus W. Got H by itself. Okay, now number 15 is different. I'm solving for y. And notice where y is. Y is inside the parentheses. So I now need to distribute to make my parentheses go away. So I'm going to distribute my A. Now to solve for y, I'm going to subtract the ax over. So I have b minus ax equals ay. And if I'm solving for y, I'm going to divide by a. So divide by a. Now, when I look at this left-hand side and I think about dividing by a, could that a reduce with anything on this side? And the answer is yes. It can reduce with that guy right there. So instead of dividing by one big line, I'm going to come in here and divide by 2 separate. And I'm going to give him an A and him an A. Because what I'm going to be able to do is, this is still going to be B over A. But when I get to this one, I can reduce my A's. And I just have an X. That one's a little tricky, so if you need to go back and listen to that one again, please do so. Number 16 is along the same line, so we have another example just like this. We are solving for y. So the first thing I'm going to do is distribute my x because that y is inside. So if I distribute my x, that gives me xy plus 7x equals 20. Again, I'm solving for y. So my first move is to subtract the 7x. So I have xy equals 20 minus 7x. Again, I'm solving for y. I'm going to divide by x. And so now you have to ask yourself, should I divide by one big X or 2 little x's? And the answer is 2 littles because he's going to be able to reduce with that term right there. So when I divide by x, on this side, I'm going to divide by 2 separate x's. These cancel. That was the point of doing that. And that's 20 over x minus, and then here the x's cancel, and I have a 7, which turns out to be D. The biggest thing, especially on number 16, just because it's multiple choice doesn't mean you sit here and you stare at it and you try to just guess the answer. But you look at how much work went into that problem. You treat every multiple choice problem just like it wasn't multiple choice and solve it and then match your answer.